So basically what we have to do is, instead of displaying all the branches that we have already defined, what we're going to do is to use the getRange method, which allows us to show not all elements of this list, of this branch list, but instead just the ones that are defined or contained in this interval. So this interval is going to go between 0 and the first time that we run this script, we have to use 1 as the, or 0 as the last item, and then 3, and then 4 more, so then 7, and so on and so forth. So if we think this carefully, actually what we are doing is taking 2 to the power of iteration count in that case, and subtracting 1. So let's see, I think I have to define this guy down there, so this is going to work. And let's see, and of course this is the last item, so it looks like everything is okay, but let's take a look at the actual result of this. So if we reset, but perhaps with a lower interval, that's right, let's start again. So now, okay, it looks nice, but actually the problem is that the tree is not growing in the way that we want it to grow. So what we need to do now is to sort the elements that we have in our list. So in order to sort our elements of this list, what we are going to do is to import the library LinkQ. So I'm not going to get really deep into this library because it can get really complex, but basically this library provides you with a lot of methods to do operation with lists, such as sorting them or extracting elements based on a condition, and so on and so forth. So it's actually really interesting. So now what we are going to do is to call this method order by descending, that again it is provided by this LinkQ library to sort our list. And this is a delegate, and I'm not going to go really deep into this explanation, but basically what we are doing is sorting each element by length. So if you remember, let's say the branches of the later generation are a bit shorter than the branches of the previous one. So if we sort our elements by length, that's a way of controlling the growth of our tree in the animation. So let's take a look how this is working. Let's reset our animation, and okay, you can see that now it's growing the way that we want it to grow. And okay, and now perhaps what we want to do is to avoid this error. So this is happening because when we run the C# script again, iteration count makes this parameter last item bigger than the actual size of our list. So what we want to do is to limit this parameter to the actual size of the list, and we're going to do it like this. So let's say this, of course we need a condition, and in this case we're going to say, okay, if list item is smaller than the actual size of our list, then and only then, sorry for that, is when we are going to call this operation of incrementing the variable iteration count. Okay, so let's see if this actually works. And okay, and perfect. We don't get any error no more because we are not increasing the last item of the list that we want back into Rhino. So let's reset the animation again. And great, so now this was our first example using recursion, and it seems like we got a really nice animation here.